that might be better.
Yeah.
And
Second.
look, everyone, I just wanted to come on tonight really to say goodbye. Unfortunately, just recently I had a stroke, and I fell and bashed my head on the corner of the bedroom door and gave myself brain damage. So now I'm deemed to be incapable of driving, so I've lost my license, and I'm not allowed to do any work, physical or mental, for the next couple of years to try and recover. So it looks like the end of my career as an arborist, unfortunately, and I don't know whether I'd ever be able to sell the business. Probably not. But certainly be looking for someone who might be interested in it. But tonight I'd just like to say how much I've enjoyed these sessions, and especially thank you, Mark, for your generously sharing your expertise with all of us. That's been a privilege for us. And thank Peter also for organising the sessions. Thank you, Peter, for that. And thank you all for participating.
And Rob, if you ever want to come past and drop in and say hi, please feel an open welcome all the time. You know, you've been a part of the group for a long time, and we appreciate your contributions that you've given and your support that you've given. And again, you know, I just do something that's pretty simple compared with you guys who are coming in and starting and working on a career. So I really do thank you for being here.
Thanks, Mark.
And if it's any consolation, you're talking to a group of arborists, so all of us have got some degree of brain damage, if that's of any help to you.
Not the degree that I've got.
Well, some of us have got it worse, I think. But you can see by the laughing faces that there are a lot of us that feel the same way. You've got to be a little bit crazy to want to be an arborist. So, a great turnout tonight, guys. Thank you for being here. Let's just start having a look at some of the questions that have come in. And thanks for sharing that, Robert. Again, great courage to share what's happening at that sort of level. Okay, the first thing I need to do is share my screen. If I don't, you won't see a thing that I'm looking at. And share, I'll do an infinity share. Doesn't like it, I know. Entire screen, share, I apologize, but let's get out of here. And you can hopefully see an image. Arakiria, I don't know who sent it in. It just came through only a short time ago.
That's me.
Who's
Colin,
me?
Colin from, that's the
Colin,
Royal Hobart Botanic Gardens.
Yeah. Something is going wrong here. We've got a few more shots, so we'll have a look at them. I opened one up and thought, oh, yuck. Well, good. Looks like we've got some woundwood going on inside, which is nice to see. Nice big shots. Thank you, Colin. Makes it easier. It still looks like there might be some necrotic tissue in behind here, and horrible as it is, you know, a good bit of board and a pry bar may give you a little bit more information. It always feels horrible to do, but you do need to know what's going on behind. Otherwise, we're second guessing. I suspect you've had something damage the roots, or you had to go the other way down. That's lightning strike down, but that to me that looks more like roots up.
These are sort of concentric photos as I go around the tree. So we're coming to the front where the large section is.
This here, though, is not too bad. This looks like it's just a growth split more than anything else. And araucarias are unusual creatures, just wonderful trees. And Bidwillii in particular, just spectacular. Yeah, see, this looks like more a growth split. And we can explain and account for that in lots of different ways. The thing that concerns me is we are getting a lot of resin production. Having said that, Araucaria has resin ducts, DUCTS, in the bark and not in the wood. Okay, that's why Araucaria is a beautiful timber to veneer with, because you can spin it and not have it tear your blades to pieces. The resin would tear your blades, which is why you don't see pine veneers. It would just be horrible to spin it. So yeah, I'm not sure. That's just not a growth split there, and it may well be the other on the other side. Although the other side there looks, I'm concerned just about what we've got. It's not got a lot of basal swelling, so I don't know whether there's been some minor grade changes or not over time.
So why would
And
you say from the roots up when we're looking at some sort of structural split here?
no, I don't think we're looking at structural.
No?
I think what we might be looking at is something that's just affected a root or a portion of the root system. Don't know. That what we want to know is what's happening in here. So hop in with a small chisel if you want, or a pry bar, and just see that we've got good tissue here. There looks like there might be some necrotic tissue there. It may not be. It may just simply be growth splits that have occurred. Araucarias can put on a fair amount of growth in a season, a centimetre or more of thickness. So they can, in
I
ideal
think they
conditions.
said they started like a irrigation watering scheme about 10 years ago. So
Yeah, so that may have had an issue. The other thing that I'm concerned about is what appears to be just indentations, like almost like the bark is starting to dehydrate a bit. That's why I'm saying I'm wanting to get in here and have a look-see, make sure I've got live tissue. It's just purely so bark has 3 layers, and or the outer bark has 3 layers, and we've got phloem on the inside. Phloem, may live a year or may live several years depending on the species of tree. And then you've got the phyloderm, the phylem, the phyloderm, phylogen, and the phylem, in that order, coming from inside out. And if it's just that area that's damaged, then we don't have an issue at all. The way you're going to find out is by finding those little creases and just seeing, is there live tissue there? If it's live, it'll just with a nick, it'll look creamy white.
Yep.
Or pink, because Araucaria. So some of the bark area is pink in color.
they have a really thick bark, do they?
Yeah. Oh, yeah. If you have a look at Araucaria, in fact, any tree, as it gets older, the basal bark gets thicker and thicker and thicker. And it's one of the arguments against, these massive big trees being used as canoe trees, is the thickness of the bark can get so thick that it's heavy. And you can see this mathematically if you go and start knocking out a big tree. You start at the tips and the bark will only be maybe 0.5 mil thick. By the time you're down a third of the way down, it might be 0.5 centimetre or a centimetre thick. By the time you get to the base, it may be 4 or 5 centimetres thick. So you could end up with quite a large, thick level of bark. If you're talking about cork oak, you could be talking about something that's 300 mils in thickness. So, and they harvest that for the same reason. And so the effect of damaging on that outer bark area, those funny 3s, the 3 ones outside the phloem, doesn't affect, in general, the long-term health of the tree. So want to get your, just small, even a box knife, anything, and make a nick or an injury around here to see what we've got. If it's a small injury, it'll produce some resin, fix it up, not a problem at all. If it's dead, then we have to start figuring out where's the limits of our dead tissue. And one of the issues that you've had is that you have been, or the garden has been using irrigation. And irrigation is one of the larger contributing factors to the spread of Phytophthora. Phytophthora is a water mold. And I don't know how Phytophthora and Araucaria go together. It's outside of my experience. I don't see enough of the two clashing. I do see lightning, and it doesn't look like lightning damage. It's a little bit, but not enough. It just doesn't have the hallmarks of it. So something ground up is what I suspect. So damage to roots in close to the trunk from it getting too moist, getting Phytophthora going in, causing damage to some of the smaller roots, damage to roots further out, removal of another adjacent tree that's caused some damage in the process to the roots. Something like that is what I'd be looking for, Colin. And then, of course, being a good consulting arborist is the big question mark. I wish I had a diagnostometer, but I don't. So I'll often be sitting there coming up with some hypotheses and then trying to support them. And if you've ever watched the TV series House, you look at that, and it's a horrible thing to say, and people, my wife in particular, hates me for saying it, but diagnosis is a process, not an event. Okay. We often think, oh yeah, I'm going to diagnose and it's going to be one. It's going to be saying, I think it's this, and I think this is where it's at, and we're going to look and manage it, and then go through that whole process again. Are we right? Are we getting the responses we expect? So hopefully that gives you some points to go through, and report back to us, Colin. Let us know. I think we're all curious now. We all want to go down the Botanic Gardens and have a poke.
Yeah, thanks to that.
No, thank you. Thank you for sharing. As I said, there's just a reasonable amount of resin produced. The one good thing about resin is trees allocate reserves to its defense system as a very low priority. So the tree's got to be doing well, it's got to be growing, it's got to be elongating before it starts putting out energy into its defense system. So trees that are stressed will tend not to produce kino, they're a eucalypt, they tend not to produce as much resin if they're a conifer, and so on. So that is the nice sign there, but it's revolting to look at. And it's just got an awkwardness to the trunk in it. But you'll find there's some really great ones if you get to Orange, Bathurst, the main park in Bathurst in Sydney, or the outer suburbs of Sydney, other side of the mountain. You'll see an Araucaria there with a massive big basal swelling and things like that. And it's not uncommon to see these unusual structures in them as they get older. Don't quite know why, but they're there. Okay. Good one. Thanks, Colin. Thanks for sharing. Next one. Okay, I have a question regarding carving hollows into live trees using cavity tools, the hollow hole, which I think, by the way, is a lovely piece of equipment, which has been gaining momentum in arboricultural industry. Specifically, I'm interested in my perspective, or any perspective, on woundwood development around the entrance piece of the carved hollow. Once woundwood has developed on the point where it comes into contact with the entrance piece, as shown in the image below, do you expect the woundwood to grow more rapidly than the rate of growth of the girth of the trunk's girth growth? Yes, it'll start coming out along that stub, and it'll want to get out, and let me make that a little bit larger for you. It'll want to come out, and you can already see it kicking its toe out here. It'll want to come out and around, and because it's sitting in a plane seat with no passenger beside it, it fills up the space beside it. There's nothing that keeps it into ring tension or helps it behave. And so I say it's like when I sit on a plane every now and again, it happens. I get a whole row of 3. I've got a brother that's a pilot, so he makes these little special nice experiences for me. And when I have 3 seats, I spread out. I've got a tray table beside me, not in front of me, and I've got, my shoulders out and the armrests are up, and I fill out the space. Whereas when I'm sitting with people beside me, I know how to eat a meal by doing something like that. So it's the same with this. The woundwood will start moving out along that thing and encapsulating it and holding it in, and that's perfectly fine. I wouldn't be panicking about it.
Okay.
I think it's a great process. I love it. I think it's a balance between intervening to compensate for our stupidity and being a little bit crazy at the same time. And I say that, for years we're getting rid of every tree with Phalaenus. Phalaenus starts to form. I've got photographs of this actual process happening. The cockatoos will start coming in and they'll start taking that decayed tissue eventually and they'll hollow it out. And that's the way they get hollows in trees. Get decay, chew it out. They don't take solid wood and chew it out. That's a hard process. So we panicked about Phalaenus in the earlier days. We panicked about cavities, and so we've lost a lot of them. And so I think it's great to see the process being short-tracked. There's not too many trees that die as a result of it or that fail as a result of it. So I think it's a good compromise.
All right. Thank you, Mark. So even though the woundwood touches the entrance piece, like I guess as in the picture, it will still grow out quicker than sort of the girth of the trunk, just because it's got that space. It hasn't connected together yet. It
will lock itself in. The pressure exerted by the woundwood as it starts to grip around, it will grip that more solid than you'd think that it's going to grip. And you know this if you've left something like a pipe in a fork and then it's grown around and tried to pull that pipe out. Good luck.
Yeah. But it wants to grow more than, like, it just tries to occlude the whole thing essentially, even though obviously the tree doesn't know how long that piece is, but it just wants to keep going to sort of.
Yeah, it doesn't know how deep that is. It just sees that as a dead branch stub, and that's exactly what nature would have. And sorry, Niels, I didn't realise Niels is a bat expert of all things, a chiropterist, whatever they are. And an arborist. Works at. Are you still working at a council in Sydney?
State government now.
Okay, gone worse. But yes, look, it's. I think for all the anxieties we have about it, I think it's the right way to go. I think it's a good balance between nature and the resources that we have. Would be better that we didn't cut down so many trees. Wouldn't it be better if we weren't so afraid of big trees? Would be better if we didn't have, we didn't plant small trees that take forever to grow. So I think, it gives us a good mix of things. And you've been finding them otherwise successful?
Yeah, so far I've been a little study on my property, and I pushed it quite hard. I sort of went, TR ratio sort of territory, risking that some trees may fail, but that's been now 1.5 years in place, and no trees have failed. So, yeah.
Look, the originator of Hollow Hog says there's been 2 that he knows of that have failed. I think that's pretty good. I think what you've got to watch is you don't want trees that are still in that rapid stage of trying to get to sunlight, where they've got a high degree of flexibility and they haven't started to develop this strengthening process. And this happens if you think about a young sapling, you can bend it quite a lot. As it gets bigger, the amount that you can bend starts to reduce. The tree starts to change the way that it forms its wood. So it starts crossing the grain, changing the angles of the microfibrils and the cellulose to make itself stronger. So yeah, great. And sorry, I hadn't, because we've got another Niels on the thing. I think this is a Niels-dominated chat. Nissa is actually now.
Must be.
Yeah,
especially this topic as well. I've done hundreds of those entrances. Just tap them in, and the window will just start growing out. It's pretty neat. No glue, silicon screws, nothing.
Yeah, you have to be batty. Okay, enough of bad jokes.
Thanks, Mark.
My pleasure. Nice to see you again. Vicky has given us a scenario with some trees, and she's assessing a mature blackbutt. Let me see if I can go a little bit bigger for you again. And she says, without going into it all detail, the tree has lost a whole pile of branches, and you can start seeing some stubs, 1, 2, 3, 4, 5, 6, 6 that we can count. And I said, I think Vicky had a lot more than that. 12 broken branches with stubs with hollows. So great habitat tree. And both Neils, I'm sure, agree that trying to keep the tree from a habitat value is really important. It's also got an injury here where a portion of it's been girdled by whatever, for whatever reason, I don't know. It's on a slope block, it's got a lean. And Vicky, if I'm right, somebody wants to build down this end of the world. Is that correct?
Yeah, they want to build underneath.
Yeah.
Like the tree will extend across. The canopy is mostly in the direction of where the house is going to be, and also it's leaning that way.
Yeah. And then there's this little hollow area down here, unsure and unclear of what that is as well. The trunk diameter, I think you gave us 1.2, was it?
1.3.
1.3. So it's only a small blackbutt by blackbutt standards. They get a lot bigger. It's probably 120, maybe 150 at the most, and perhaps 80 to 100 at the least. So it gives you a range. It is on slope soil, so it's probably a little towards the older end rather than the younger end, because moisture is a little bit harder to get when we talked about this last week. So your questions are, how would you go about dealing with this?
Yep.
Assess it just as it is. There's not a lot of load on the tree. A lot of the branches are shortened down, nowhere near as big a crown as I'd expect on a blackbutt. It's not perfect. It's got age wrinkles. You've got age wrinkles, you get shot, or you accept that age wrinkles are just a part of maturity and you keep it. Now, having said that, my advice to the client would be expect branches to fail occasionally. We don't know what those branches failed in. All those branches could have failed in 1 or 2 severe events, or as a result of 1 or 2 severe events. But I would say it's fair and reasonable to expect trees to shed. They're defined as shedding organisms. So if you're going to have a tree over your roof, expect some periodic damage, particularly during inclement weather. And my suggestion would be go to corrugated iron, but keep your trusses close. So a few more trusses than you normally would. Metal roofs, you can, because there's not as much weight, you can have wider trusses. Keep them as though they're a tile roof and keep them closer together. It costs a little bit extra, but the impact from a falling branch is minimal. Having said that, this is in an area that's close to water by the looks of it, is it, Vicky?
It's in Grace Point.
Yep. So there may be height limits, and that may mean that they want to change the way that they're going to do their roof. And that's a discussion that the design team need to have. So I give that information to a design team. I would say 9 out of 10, just throw it in the bin. He's just the arbitrist. What does he know?
Would you prune it to take a lot of the weight out of the branches?
I wouldn't prune anything that was green. Is how I would handle that. These the parts that I'd expect to fail on this are going to be largely smaller pieces.
Right.
This is a tree that's now acting more like a static mass than a dynamic mass. That is, the whole tree doesn't have that same sway that a normal tree would have. And so it's acting more like a mature to over-mature tree, or a static tree that's just solid. And then these bits at the ends are swaying, and that's where stronger winds will tend to lead to failures. Now, I would say that there's benefit in having the tree pruned, just to check what's there. I'm of the view that leaving stubs has some advantages now. Niels, if you're there, be interested in your comment on that. There's an advantage in providing a roost for birds, even if there's a hollow in that branch, rather than taking the whole thing back. So specifying that, I think, makes good sense. It's the same when you have a cavity. If you've got a branch below a cavity, I know that they're weaker, or they may be weaker. Reduce them or leave them as a short, maybe half metre or metre stub, so that at least there's a perch there to better use that nesting spot. Niels, is that your view on the world?
Yeah, I'm here. So
Yeah.
you mean like leave a perch there or leave the hollow there?
Yeah, leave. Don't. If this has got a hollow, try and give 200-300 mils at least of length there, and just let that degrade over time, rather than trying to cut it all the way back through. It's a lot easier for something like a parrot to land on the top side of that branch and then drop itself down into the hollow than to try and fly directly into a hollow.
Yeah, I think that's right. Yeah, there's some commentary like in scientific literature that they suggest perches are not needed in Australia. But yeah, it wouldn't hurt, I reckon.
Yeah.
Well, I do that all the time, but I keep getting told off by different councils for leaving stubs.
Well, I know that at some stage or other, the Australian standard for tree pruning is up for review, and one of the things you'll see in that will be the introduction of fracture pruning and environmental pruning, coronet cuts, things like that. I think we've got to see trees as more than trees. We've got to see them as a part of a whole ecosystem. And that means sometimes there's compromises from the ideal cut that may have its advantages over the ideal cut. And a good example would be Francis Schwartz's work on fracture pruning, or just breaking branches off, and fungal diversity, and shows that there's greater fungal diversity if you don't sterilize the tree by pruning off all of their branches, and that's because you're changing the microflora within the ecosystem when you cut off all those dead branches. Different fungi form above ground than you do on wood at ground level, and that makes good sense to us all.
It's bushfire prone. I'm waiting on the bushfire report, but I'm expecting they're going to say it can't extend over the dwelling.
Yeah, if it is in an asset protection zone, that will be what's required, even though the code says should. It doesn't say shall or must. And although the concern is that this may catch alight, a branch may burn through, drop off, and cause the steel framed steel roof to catch on fire. My experience has been that steel, whilst it is combustible, is usually not set alight by a burning tree. So I don't quite get it. The other argument is the piece could be big enough that it breaches the roof. And I guess that's a possibility.
Though you can't see all the canopy, it will extend over quite a long way.
Oh, I'm sure. And, my gut level feeling again is that during a fire, you might end up with some bigger bits falling on the roof, but that's the least of the problems they've got when there's a fire. And it's amazing just seeing how our standards for construction in fire zones has changed so markedly. And sometimes we get to confusing things because fire people think of trees from a fire perspective, not always from a tree perspective. So, for example, I've been asked to support the removal of a camellia near a house because the camellia might catch alight. And I said, try it. Throw one in a fire and see what happens. But there's casuarinas, and we all know how they burn. And the answer is they don't. They're really slow at burning, amazingly good at catching embers and reducing fire attacks. We've got to stop seeing everything the same because casuarinas look like pines. People tend to think of them as pines if you're talking about Pinus radiata. you can burn the greenwood easier than you can burn it when it's semi-dry, because the amount of resins and the amount of terpenes they're in it, so they're quite combustible. So yeah, just like our eucalypts are, and I do appreciate the fact that they're combustible. More combustible than this is a cotton palm. If you haven't seen it, go look up a video for a cotton palm catching on fire and burning incredibly fast, incredibly quick. And then look at the damage done to the buildings nearby. And it's inevitably the case, they drop fronds, the building stays, nothing happens to it. So falling debris, if you've got a metal roof, particularly if you've got a metal roof with a fire retardant system, spray system on the roof, I would say let it overhang. But those that do fire reports tend to be paranoid about trees overhanging, and I have yet to win one through. I've given up on I will always fight for it because I think that's the right thing to do. I'm there as an advocate for the tree. But I accept that there are other things that are important apart from just the tree. And the same extent, I'm an advocate for the development, in the sense that, the development needs to go ahead. We need to put houses and people somewhere, but I've got to weigh that up. Can't keep every tree. Some will go.
Okay, great. Thank you.
So just record it as it is. I mean, just the facts, Jono, just the facts. Give them the facts. Let them make some decisions. I am not the consent authority. Now, again, Niels has been in that job as a council arborist, and there is a degree of pressure that even councils feel, and he can say yay or nay, to allow development to occur. It's a part of the process that we live in. As a country, population is still growing, and so we want expansion. I mean, it's an artificial Ponzi scheme, I think, but we still have that as our reality. Okay. This one is from the other Niels. Hi, Niels.
G'day.
And Niels, just so you know, it's called Nisse because people can't remember to say Niels. It's too hard. Isn't that funny?
It's a hard name for Australians, for sure.
I just
it's really Niles, isn't it? Whenever they see my name, it's Niles rather than Niels.
I get Nis a lot. That works too.
So this is a plant hopper on a eucalyptus, dead eucalyptus, but it's not feeding there. It's just simply habitating there. And what's really great is correctly identified. So it's the red line gum tree hopper. And if I went back 5 or 10 years ago, past students will say to you, we'd collect samples and we'd bring them in. And photographing is a great way to do that. I will tell you that getting yourself a collection of photographs that you have identified of things that you see is a really valuable resource. During your diploma, I think you're meant to do, I don't know what it is now, but it was 200 diseases at one stage. I think it's down to about 120 or 80 now. And that's a really important resource for you.
I'm pretty sure it was like 10 fungi and 10 pests or something. It was bugger all.
Don't tell me that. I don't want to know about that. But anyhow, yep. Niels, can you remember how many you had to do?
Not exactly, but there was a lot.
Crap loads, yeah, scientific term, crap loads.
Yeah, we didn't do many at all.
It's a worthwhile skill because you learn how to deal with the diagnostic processes. You learn how to identify when something's unusual. This is a hemiptera. Hemiptera and hemiptera used to be together at one stage, different. Now they're together. And so this has got a little sap-sucking component under the underside of it. Got a proboscis. It's like a mosquito's got a proboscis. It's not in the same group at all. But this sucks stuff out of the plant. And most of them are plant feeders. A few of them aren't. The giant water bug that's eaten as a delicacy in Thailand, for example, is not about sucking plant sap. And these can feed off plants, or sap-sucking insects can feed off plants in a number of different ways. So we call them sap-sucking, but that's a very broad thing. What is sap? If we're talking about
That's what I
sugary,
thought when I was reading all the information about it. Just said sap, and I'm trying to find what. Give me some more
what's
information.
sap? Yeah, I wish we didn't do it, but I mean, scientifically we're poor at it. So there's those that feed on the inside of cells, things like psyllids, for example, that you see damage the leaf and you see the leaf go brown. That psyllid is a cytosol feeder, so it's feeding on the insides of a cell. Then you get the phloem feeders, things like aphids, and you see them on the bottom of the leaf because the veins, the bottom side of the vein has a the phloem is at the bottom, the xylem's at the top of the leaf. So the vein is split top and bottom. So phloem feeders, they're fairly common, and they'll also be on branches because, again, the outside of the branch, thin bark, you've got some phloem. Then you get a really weird group, and that weird group is the xylem sucking insects. So they actually from water inside the wood, and our classic group for that, cicadas. And I suspect that's part of the reason why cicadas take so long to get to maturity. You've got to suck a lot of water. And one of the things you can go and have a look for on the YouTube videos is cicada rain. Cicada rain is just another way of saying I've been peed on by a cicada. It's pretty amazing to see. I've seen it once in my life where I just thought that there was a shower going on above me, a light shower, just coming out with those sort of quantities. Those that feed on water have to get rid of most of that water to get the food they want. They take a whole pot of water and they get some amino acids and some bits and pieces that they want. They don't want a lot of energy, so it's a fairly slow process. The ones that feed on the xylem, on the phloem, they've got a whole pot of sugary stuff. And while sugar's great, it's not good for bodybuilding. Go ask any professional bodybuilder, Arnold Schwarzenegger. Go have a look at him on a diet. Be lots of amino acids, yes, but not the sugars. Cut the sugars out of your diet. So these guys have figured out a way of dealing with that. They put the sugar back out. Okay, process called denitrification. They're after the nitrogen and the amino acids. They don't want the sugars. Put it back out basically as sucrose. Comes in as sucrose, goes out as sucrose. It falls. We call that honeydew when we see it falling, those fine filamentous threads. So wonderful to see. Again, leaves a sticky surface. Aphids are notorious for it. If you've got oaks, you've probably seen oak aphid at some stage or other. Colin, I don't know whether you've got oak aphids in Tasmania. I think we might have kept them away, but you definitely have aphids. So you'll see that black sooty mold, developed sooty mold, is from the phloem feeding insects. The cytosol feeders, they're fairly efficient because they've got a balanced cell, and that's what they're feeding on, the inside of a balanced cell. So they don't deposit too much. If they've got excess sugars, they'll often form it into a waxy compound. Wax is just a really highly modified carbohydrate. So we get the sugars and combine the carbons and the OHs and keep on combining, produce a waxy thing. So you'll get covered tests. You'll get psyllids with the covering. That covering is called a test or a psyllid, either way. You'll get all sorts of structures built out of the waste products. But you tend not to get anywhere near the same amount of falling debris. So you can have a nice psyllid infestation in a tree and really not know. Okay. These little except the daffodils.
Let's say you go.
Yeah, and you'll see the same thing if you've got viburnum hedges. Viburnum hedges and mites, for example. Mites are another cytosol feeder. They're cutting and pulping, but they'll essentially do the same job as a sap-sucking insect. And you'll see the cell can turn brown or it can turn stipuled. Let me find stipuled for you, if I can. No, that didn't work, did it? Thank you. STI, does anyone want to correct my spelling? STI PLED. No, not allowing me to. Oh, help if I type on the right keyboard. STI. Yeah. So this silver grey effect is caused by those cytosol feeding insects. What they've done is they've taken the insides out. The cell is dead and it's just got a cellulose cell wall. So the canvas sac is there, the white sac. And the white sac then gives you that white appearance. Make sense? So just by watching what the insect's doing in the tree, you can start now to putting it down into smaller groups and taking things out. There are some other insects in that group that are just really amazing, that do weird and wonderful things like eat other insects. So assassin bugs and crusader bugs that are good guys. So they're not all bad. I've seen a Hemiptera take a orchard butterfly caterpillar about 5 centimeters in length and eat it in one day. So, it doesn't sound like a lot, but if you get 2 or 3 of those in a tree, they can be very beneficial. But if you're seeing this, that's the first thing you're going to start thinking is, do I have something that's taking the cytosol, the inside of the cell, out and just leaving me with a shell wall? Yep. So keep gathering your insects and then start thinking on any disease, think about putting it in to some degree of order. And so my suggestion is, beetles, caterpillars, Hemiptera, just put it into your orders, and then start breaking it down in that folder and then getting it more and more. You'll always find it valuable to have this information. And then who knows, one day you might turn around and do something. If you send something like Brisbane Insects, for example, is a great site, lots of useful information. I'm waiting for the first arborist that says I'm going to do it for trees, insects in trees, and look at all insects that affect trees, and it'd be a great little publication. To some extent, Elliot and Jones have done that, just not specifically with trees and not so up to date. Okay, blackbud I've got. Shot hole borer.
What's another question with that?
Sorry, what was the other question?
I've got another picture. Sorry, if you scroll down.
Oh yes, I saw this.
Yeah.
It's a cut that's been made, some woundwoods developed. Cut wasn't the best, I'm sorry to say. I don't know who made it. It was yours. I'll charge you.
Not me.
But the tree is really healthy. It's producing lots of kino in response to injury. Where's it getting injured? Just closing over that wound is an injury. Okay.
So that's just kino, is it? The orange stuff?
Just kino, yeah. Just kino with
just
water
amazed
added
by the color of it. It's so orange.
Yeah, it's just been watered out a little bit, diluted down. Otherwise, it'd be a more darker, reddy purple color. But yeah, and you can check that it's kino. I'll do it for you just because I do like you. Take about a pea-sized piece, have a chew. When you feel your mouth drying up, that's tannin almost certainly. Then go give yourself a few good drinks or something to get rid of that horrible, dry, astringent effect that you get from tannin.
And I know that tastes very well.
And it won't kill you, so you can use that just to confirm. But that's what it is. 100% certain of that one.
Thank you.
My pleasure. Catherine Russo, you online? No? Okay. Catherine's wondering what's happening with polyphagous shot hole borer. And I do have my inside people in Western Australia that I've been dealing with. I've had the pleasure of being consulted with and asked to go over and look at the problem. It's complex, but the Western Australian government has given up. So they've decided that they're not going to eradicate anymore. It's about management. So I was at a risk assessors conference in Melbourne a few years ago. Lots of people from biosecurity there. One of the presentations, really great presentation, the presenter made the comment, why bother trying to prevent it? Let's just, this is about invasions generally, said, let's not think about stopping it. Let's think about how we need to manage it, because it's inevitable. It's just a question of time before we get things in. And that doesn't mean we shouldn't be vigilant and try and stop it, but I think we've also got to accept the inevitability. So this is coming to Victoria. This is coming to New South Wales. This will get to Tasmania. It's just going to take longer, Colin. Okay, but it will get there. You know, we gave you phytophthora in Tasmania. You didn't stop that. You know, those of you, if anyone's on from New Zealand, we gave you possums. That was a good one. You know, and we don't have to necessarily do anything more than have one female move across that's able to, that's fertilized, able to give lay eggs, and we've got a problem. We don't know how it got into Perth, and it has been a lot more devastating than we first thought. The obvious trees are trees that are nursery trees, that is where eggs will be laid and pupae will, or larvae and pupae will go on. And that's trees with low levels of extractive, so poplar, willow, acer, and you sit there and say, yeah, well, that's not too bad a loss. I don't mind a few less of those. And then you get the secondary things that we don't expect. Platanus, ficus, and ficus is just a devastating thought. They've been doing work with trying to control by filling holes and filling them with poisons, all sorts of things. Largely, they've been ineffective. There's been an attempt to try and regulate the problem by regulating the fungus. So there's a fusarium. So typical of this group of beetles is that they produce, or they bring in with them through a thing called a mycangium, they bring in a fungus. And that fungus helps digest the wood and gives them things to eat on. And it's that fungus that's causing the problem. So there has been attempts to try and regulate the fungus, but largely the government tried to put a stop to that. Now that we're at the control stage and not eradicate, I think we'll see a lot more experimental work go on. But I will be surprised if it's not in Sydney in the next 10 years. It'll come via Victoria. And Victoria's biosecurity is really good. Each state, so Smith in Victoria, Carnegie in New South Wales, and I forget who in Queensland, all have a strategy. The DPIs all have a strategy to try and prevent this from coming in. But, you know, I just think it's a question of when. And it will cause problems. You see it in some species of eucalypts. So it's not just the exotics. And I think that's been surprising. And it's not just the trees with low vigor, but trees also with immense vigor, things like platanus. Amazing to see. If it just attacked camphor laurel, for example, no one would give a damn. But it really is, when you start seeing figs struggling with it, it's really quite a sad situation. Any questions on where we're at with that? So just vigilance. People that are bringing plant material in from WA shouldn't do so from the the zone of contagion, but it probably wasn't brought in on a plan either. It was probably just on a little bit of dunnage or a little bit of timber somewhere, and that was enough to create the problem. And it'll only take a kid to pick up a stick and put it in the back of an RV, and we're in that same situation, if that makes any sense. And it's not the end of trees in WA, but it certainly has had an impact. The eradication program was probably worse than the borers, and that's because the eradication simply said, "Oh, we've got it," and the fig gets cut down. So they did do a fair bit of devastating removal before there was local community and local government kickback, and particularly the city of Perth was very strong in saying, "No, you're not removing our heritage fig trees. You need to find other ways." And some great work. If you haven't seen the presentation, go to one online when you get the chance. But things like using LiDAR to plot all the branches and show where the infestations are so you can monitor. They're using a latex-based paint with an insecticide in it so that when the insect comes out of the pupation gallery, it effectively destroys itself, and that's been shown to be somewhat effective. And I think those are the things that we're going to look forward to as somewhat effective, not going to be perfectly under control. Happy with that? And I think we've covered Colin's one from last time. That is, what do you do for root investigation? Colin says yes, which is great. I had an interesting discussion, and I saw Samantha Ning was on earlier. Maybe she's still there. A discussion about where we're at with roots, and I was just she asked me for a copy of a document I did on tree roots a number of years ago, and I pulled it out and was about to send it to her. And that usual horrible process, you start going through the document and think, "Oh, how did I write that? And how did I make that look like that?" And one of the things that was interesting is I was getting towards the end of the document, and I noticed how much things have changed and things have clarified. So the clarification: roots exert a lateral pressure or a pressure sideways of about a megapascal. We know that. That's about the limit. Some less, some more. It's a great little article by Andrew Coase. We discussed that last meeting that we got together. But that was nice to see some reinforcement of stuff that we already had. In the earlier days, roots got in a pipe. There was this push that said, well, tree owner's responsible. In New South Wales, that's changed a hell of a lot. The last few cases that I've been involved where roots and pipes are involved, the terracotta pipe's old, it's got 40 joints, it's leaking. The pipe owner now has some responsibility. It would be like saying, well, I painted my house 40 years ago and it was beautiful Dulux paint and it was guaranteed to last for 20 years. And I know it's been peeling off and everything else, but the shade from your trees is increasing the humidity and the wood's rotting away. It's your fault because your trees are increasing the humidity. Well, no, your paint was going to last for 20 years. You've gone to 40 years. Clean it back, finish it, and paint it again. And the courts started to make decisions more in that direction. That is, there's a limited life expectancy for terracotta pipes. If you're getting to that age, and they all are now, because terracotta essentially started to eliminate in 1970s. So what's that? 50 years ago. All those old terracotta pipes are old and they need to be maintained. Well, who's going to maintain them? Well, nobody does. They just wait for the joints to fail and things to happen, and then all of a sudden they start whinging about the trees and tree roots. So that's the first thing. The second thing is the court has now made it quite clear that the person's not responsible for their tree roots and the neighbour's pipes until they knew or should have reasonably known that the roots were doing that. Well, I don't know about you guys, but I don't have X-ray vision. So the time that I get to know that there's a problem with roots in pipes is when somebody tells me, and they've done something to verify that. Because of course everyone wants to blame the tree roots for everything. It's like anything that happens to a house, if there's a crack, it must be the tree roots. It can't be, for example, a leak in the pipe system that's causing the foundations to sink. And I've seen that. Went underneath a house where the roots were, the liquid amber were damaging the building, saw the crack opening up in the wrong direction, got a spade out and was able to push the spade all the way through into the wood with just 2 fingers. It was that wet in the corner. And I said, no, if anything else, this poor liquid amber has been keeping your building from cracking as badly as it will if you don't sort out the moisture problem. So our position now has been, well, I'm not responsible until I know the damage that's occurred at the point I find out. That is, they put down a camera and they said, look, there's roots everywhere, there's problems everywhere. That now is on the pipe owner. It's when the pipe owner first knew, and the tree owner couldn't have known before then. So when the tree owner knows, then there's some burden of them to do something. And the last few decisions that I've seen on the matter, the courts have turned around in New South Wales and said the pipes are aged, they need to be replaced. If they're replaced, then the tree roots aren't a problem. Fix the pipes. And so the costs have fallen where they currently lie. That is, the owner of the pipe work has to fix it. Tough luck about the neighbour. I was lucky enough to be involved in another case a couple of years ago, 4 years ago, where there were already some big existing roots, and a builder had demolished and was rebuilding. And they said, look, we need to get rid of these trees because you can see they're in the existing drains. The existing drains are being upgraded, but they're already causing problems. And in that one was really interesting, as the court said, you need to design and build fit for purpose. That is, you had to make sure that your plumbing work was good to deal with the fact that there were roots around. You had to have thicker pipes, and you weren't going to be able to, the applicant wasn't able to get a second suck of the cherry in 10 or 15 years' time when roots were all of a sudden causing problems with their drainage. Because what the courts have said is, that's your problem if it is, because you haven't designed and built your drainage system correctly. And there's some good common sense in that. So some fairly big changes since 2015, subtle as they might be. The tree owner's not responsible until they know. There's been some push of an argument, say, well, hang on a second, you've got a fig tree, you know it's got roots in the pipes. Well, there are lots of fig trees without roots in pipes. So you know you can't reasonably know just because it's a fig tree. The equivalent, Colin, London plane tree. Just because it's a London plane tree doesn't mean it's got roots in the pipes. And of course it wouldn't have if the pipes didn't leak. Okay. And if you think about it, you've never seen a root grow through, and I see a question there, Colin, so I'll be with you in a second. You've never seen roots grow through a plastic pot, for example. They'll split it, but they'll never grow through it. You know, so pull a plastic pot out and all of a sudden say, oh, look at all these roots that have just bought. It doesn't take a lot of thickness to stop roots penetrating, and it doesn't take a lot of thickness to stop roots from crushing. In fact, hang on a second. There's the stormwater pipe, and I'm pretty positive that nothing will ever crush or break this pipe. Okay, how am I so positive? I can drive a truck over it and I can't crush it. So if it's possible, and this is stormwater pipe made for long pull installation, directional boring. So the stuff exists. It's just a question of making people change the way they do things. Yes, Colin, question.
Yeah, not so much a question, just in regards to diversifying revenue streams and roots getting into neighbors' pipes. I find that it's doing root barrier is quite a common thing that comes up in those situations? Is your experience with it? How effective is it? Useful? Is it useless?
It's somewhat effective at delaying the inevitable. It certainly is a benefit, but there is some trees, for example, figs, one of the great ones. Figs will either go up over the top of it or go down underneath and come back up, and will even graft themselves together if they can do it quickly enough. So yeah, it's pretty amazing. So barriers have some benefits, but if a plastic barrier can stop the roots, then why aren't we having a plastic barrier that stops the roots? It's called a pipe. It just seems to me that you can roll that plastic barrier up into a tube, and when it's of an appropriate thickness, the problem's solved and finished. It's done. And I'm not suggesting that it has to be 1 centimetre thick wall like this is here. Just, standard pressure pipe, under all probability, is probably going to be fig root free. And the reason for it, and I had the article up, so I can probably put it up fairly quickly. There is some maths behind it that's fairly simple, and some physics, but where are you? There we are. If we've got a root against a pipe, this is our root, and it's pushing down on this pipe, top's under compression, bottom's under tension, it wants to flatten it, but the soil on either side is stopping it from being flattened. Does that make sense? So it takes a fair bit to get it wrong. If this was sitting on the surface and there was a root immediately below it, then it's going to lift and displace it. And shame on the plumber for putting the pipe on the surface. So again, once it's down 6 times diameter, 600 mils, nothing's going to happen. 300 mils, it'll be okay on a probability. And it'll take a fairly big root to displace that. And the picture that I use to demonstrate that is this one here, and I'll zoom in on it. But that's a pipe. It hasn't broken. Nothing's gone wrong. It's just started to be completely occluded by the tree. Okay, so again, we can make a pipe well and truly strong enough. I challenge you to find me a root that's that size. It's just never going to happen. And yet I've got all that surface area, and the pipe says, yeah, okay. Keep it going. Happy with that? So, yeah, unfortunately, tree roots cop the brunt of our criticism, and I found it interesting. The other thing that Samantha raised, and hopefully she is there, or hopefully she'll catch this on the replay, but is engineers have this wonderful capacity to say there's a big gum tree and there's a cracking in the wall, or there's a lifting of the building, or something's happening, and therefore it must be the tree root. And there's a point to which there's a reasonable assumption sometimes in that, but there's also a degree of uncertainty in that. And so how do I know that the corner of the building's not slumping rather than the other portion of the building lifting up? And so the tendency for engineers is to draw a causation from correlation. There are trees and there's a building, therefore the trees must have caused the damage. And there was a great post a number of years ago on a arborist website that said, from construction engineers, said where there are trees around, they're the cause. When there's no tree, there's some other cause. And that was just a completely logic fallacy in the whole process. If there's some other cause when there's no trees, we've got to at least consider where there are trees, some of those other causes are at least the cause or a contributing factor. And the other thing I pointed out to Samantha was why are building footings wide? Why are they 500 mils wide? Does anyone know? It's to stop the building from sinking. So if I need a 500 mil wide footing to keep the building stable, how will a 200 mil wide diameter root all of a sudden support a whole big chunk of the building? It won't. It'll get pushed into the ground. And that's inevitably what happens. Either the root is inhibited from growing, it just can't grow anymore, it's stopped. So I have a septic tank here that is filled by a piece of willow. The willow grew through it. We cut it off, the willow grew through it. We cut it off, the willow grew through, could no longer grow, and it's just a solid chunk of really dense compressed willow that's blocked the sewage tank, the hole. And so that's all that happens. It's eventually going to destroy itself. It's not going to split my tank open. And so the root is just like a jack. You're jacking underneath a car. It's a little moist in the soil, and all of a sudden your jack starts sinking into the ground. And in the early days when we moved big trees with hydraulic jacks, we would use jacking styes. The styes, your timber goes one way, timber goes another way, timber goes another way. And so you just keep on crossing them over at 90 degrees. And we'd run full-length sleepers as a base, and we'd watch them sink in the ground. And that was with only 50 tons on. Think about the weight of a building and think about how likely it is a small little root of 100 or 200 mils in diameter has got any chance of lifting, a fairly heavy building. Now, there's some design faults that do weaken a building, and I know we've looked at them before. Things like glass windows aren't exactly strong. So you've got very shallow walls, poor footings, and glass windows. Well, they can crack. But in general, tree roots won't damage buildings. They'll lift a concrete slab, a driveway slab, they'll lift a path. And it's possible to design both those so they can't be lifted by roots. So just something to think about. Things we're learning more. And again, I would say if I was a city or a council, I would say, yes, we're happy to look at the problem with the roots that have done to your driveway. The damage is already done, so we can't do anything. But hey, when you fix it, you better fix it so it's tree root resistant. If you don't, we're not going to pay again. And of course, if it's tree root resistant, if they fix it with a tree root resistant solution, then they'll never have to worry about it again, so the tree can stay. Cut off a few roots, not all of them, but a few roots. And the driveway. Notice they don't lift deep footings in general. It's just light footings. Any questions beyond that, guys? Vicky.
Yeah, I've got a question, and it's about tree roots. I've got a project in Cremorne, and 2 Melaleuca quinquinovius, street trees, roots bubbling up over the edge of the footpath and driveway. The client wants a new driveway, new crossover, new garage. How much clearance above the roots do you think I need to specify for the new driveway crossover?
It's more the strength of that driveway crossover and what holds it down. So the problem with the driveway crossover is it's light, and roots can lift light structures. I've got a megapascal jack, and you work that out. Megapascal. It's I'm just trying to work it out in a conversion rate in my head. We lift whole trees with about 1/10 of that conversion rate, not quite, about 1/8 of that conversion.
I think it's about 120 psi on the old scale.
Yeah, thanks, Peter. It's I think a tad more, but yeah. So we'll lift trees with 20 psi and enough surface area. So it's about getting the mass to stop it from lifting. So tying it down to rock underneath. If you're in Cremorne, there's probably rock fairly close. If there isn't, then piers, so that you've got friction is a solution. And then you don't need any clearance. You can go right on top of it.
What do you mean by tying it down to piers?
So get the engineers to do this, not us, but we would do things like put in a pier. Now, a pier's something that goes straight down into the soil, and it creates friction and mass. And what we want to do is we want to make it so heavy that it can't lift it. So all you've got to do is say, you're a structural engineer, look, roots exert a pressure, trees exert a pressure of about a megapascal. So you need to design and engineer with that pressure in mind. And they don't. For example, with a wall, they'll say, oh, yes, brick wall, clay soil, moist soil exerts a pressure 400 kilopascals. Well, 400 kilopascals, you're 2.5 times that is what a tree's pushing, and you haven't considered it. So they'll push a retaining wall over. Engineer for it, and it won't happen. So their job is to do the engineering. But typically, it'll be something like ground anchors or piers into the ground to create friction and mass. And then you don't need to do much more than that. I would look at, if you can, using something like void form, just to give a bit of space. Let me just close that.
Because the council have come back saying we need to do route mapping, but obviously we can't do any more route mapping until they pull up the driveway crossover and the footpath. And they've engineered the level. Like from when I first did my report, they've come back now and everything is 100 mil lower, which is all, you know, closer. Like it's ridiculous. It's all going to cut into all the routes, and it's just not acceptable. So I'm just not how to specify what they need to do.
Yeah, look, ideally, it shouldn't be the invert of the driveway shouldn't be any lower than the existing driveway.
That's right. Yeah.
It currently sits now. That's your ideal. You could potentially lose 1 or 2 routes without being a problem at all, depending on how big they are and where they are. Remembering that in general, you can lose 1/3 of the first order routes, and a tree's not going to be significantly compromised by that. Now, obviously, that depends on how big those roots are. You don't want to pick the biggest 2 that takes up 90% of the root system if you've got a asymmetric root system. But if it's got an evenly distributed root system, a couple of roots is probably not the end of the world. Void form is this stuff here. It's cardboard form, and it just gives a little bit of a space and an air gap. It's really neat because it degrades over time. It's cardboard. Okay.
Yeah, I worked on a project at Beecroft where the engineers, they put piers down between, and they elevated, and they used this type of structure, and they elevated the underneath side of the concrete driveway with 100 mil clearance from the top of the roots that we exposed.
Yeah, we can get this in anything from about 2 centimetres upwards, I think. And 2 centimetres is probably only a couple of years growth for a healthy eucalypt, if that. But that's all it needs if the slab is appropriately engineered. You cannot lift the unliftable. And that's all we're trying to make. We're trying to make the driveway do 2 things. We're trying to make it heavy enough by friction to what it's attached to, you know. So if you could put it and attach to the rock and pin it to the rock, that would be perfect because you won't lift it. But you put piers down, and those piers add friction. It's like trying to pull out a fence post. Okay. So friction adds mass. So
and should they do the same thing with the driveway, with the garage as well?
Yeah, look, the garage is probably going to be 150 mil garage slab.
Right. Yeah.
With Rio mesh and wall on it, probably brick for Cremorne, and probably a tile roof if it's typical in the area. There's a fair bit of weight in that already. Okay. So appropriate Rio mesh and appropriately laid. I'm not going to criticize another trade, but sometimes concreters have problems getting the mesh in the right spot. Too close to the top or too close to the bottom is problematic. And the other thing is, Cremorne is notoriously harder in some ways because there's slightly higher saline content, and so you need to take that into consideration as a concreter. So I don't see it as impossible to put something straight on top of a root system. I've often said you could easily engineer and design a pathway over the fig roots so that the pathway would never crack. It would just have to be an appropriate thickness, so probably 150 mil, probably 42 MPa with Rio mesh through it. But we're not talking about that when it comes to a eucalypt. We're talking about a lot fewer roots, a lot deeper roots. So I would imagine something like 125 to
Melaleucas, they are Melaleuca quinquenervias.
Yeah, Melaleuca quinquenervia, yeah. Talk to the engineer, he'll figure it out, but I imagine somewhere between 32 and 42 MPa concrete, somewhere
Yep.
between 125 and 150 mils thick, and enough mass that it can't lift the weight. And he'll
Okay.
figure all of that out.
Yeah.
And if he
Okay.
can't, he can give me a call and I'll talk him through how to figure that out. But
Yeah.
because it's not their standard computer programming, it's not the standard modeling. So sometimes they just need to think it through, and it's sort of an alien thought to them. So it's thinking differently than what they're used to. Yes, Matthew.
Are there any good papers about how your saddened trees can generally lose a third of their first order roots? Are there any general papers, or is that just like from your experience for so long?
That's from the fact that you can have a cavity that's got a 1/3 opening,
yeah,
and the tree's not significantly compromised. Now, if I go to cavity 1/3 opening, hopefully we'll get a few up. Tree, not tooth. A tree with cavity 1/3 openings, not generally going to be something we worry about. Every root that was connected, so I'm going to pull up one of my photographs instead. I'm going to get it off the net. Every root that was connected to that basal cavity was once a living thing. Now it's dead, gone, and decayed. So not giving any support. Cavity. So tree can lose 1/3. Lots of texts, unfortunately. There's a typically hollow tree. I apologize for the quality of the image. It's a little bit better. I mean, there's nothing here that we need to worry about. There's nothing connected down here. So if it's lost all those roots, then how important are they? Here's one with Mike Ellison. It's got roots wanting to come down the inside. It's got mostly gone. It's not a problem. Now, in fairness, this tree has been pollarded, so it's probably not the same thing. But this, nothing here is living anymore. It's not supplying. So all the roots that are giving support have to be attached to the living part of the tree. So if we can have a 1/3 cavity in the tree, not significantly compromised as a result of it, it stands to reason that we can lose 1/3 and not have the tree significantly fail as a result of that.
Mark, was it Hamilton that talked about root loss and how it's affected trees?
Yeah, Hamilton says that up to 50% of the root would be a significant impact, but usually won't kill the tree. Having said that, I think it infers two things. It doesn't say it. It infers two things. One of the things that infers is that there will be a modicum of aftercare. Somebody will take some responsibility, and that it's not going to just be at the trunk. It may well be off, and then like a curved cut or a two sides type thing. I just want to talk about this tree. This is an interesting tree. It's a tree that had a cavity up to here. You can see where it once was. It's been occluding over slowly but surely. When that was like that and open, I had just started in arboriculture, probably about 3 or 4 years in, and I saw the cavity and I said to Phil Hewitt, who was a lecturer at Ryde at the time, I was with Phil and he lived just down, or still does as far as I know, lived down the road there. And I said to him, I'm amazed that the council leave a tree like that. Now think about that. Nowadays, we'd look at something like this, and even if that cavity was still open and it was, 70 or 80% decayed, we'd probably still say leave the tree. At least I hope we would. So things have changed. Colin.
Yep, I've got this paper by you, an allometric method for assessing data from root investigations.
Yep, and it covers that issue there.
Yeah, I don't have a date for it, so I can't reference it properly. Can you give me a date, please?
Yep, not last year, but the year before.
Oh, yeah, okay. That's what I had somewhere, 2023. Yeah. Nice. Easy. Thank you.
Yeah. And so that paper discusses that issue, Matthew, and it says, if we can have a fire come along, burn this off, burn into here because it's got a cavity, it catches the light, and we lose just 1/3 of that tree, and that's the only effect of the fire. There was some logs stacked up against the base of the tree, so it hasn't done a whole pile up in the ground. We just leave the tree. We wouldn't turn around and say, oh, look at this poor tree, it's got a 1/3 opening. Oh, it's all those roots that it's lost. So from that, I infer that I could cut this root here. That one root. Tear it out. Not suggesting we want to do it, but I could. And the tree probably isn't going to suffer physiologically and probably isn't going to struggle structurally. So let's deal with those two. Physiologically, the bit that the root system does its most critical is at the ends, and it's the bit that takes up water, absorbing. And absorbing roots typically last, if they're not mycorrhizal, they're just going on their own, a few weeks. Not very long. So they're being replaced all the time. And they're being replaced all the time. I wonder what would happen if I just got rid of some of this grass, put down some mulch, improve the environment, let the remaining part of the absorbing root system develop well. If they're mycorrhizal, same deal. They're going to maybe live a year or so. But again, we can stimulate them and replace them. So by just improving the environment, we can replace what we lose fairly quickly in a matter of 12, 16 weeks, something like that. We can essentially regrow a new absorbing root system by just using water, creating a better environment for the root system. Remembering this tree was once a forest specimen, or wanted to be a forest specimen. So that's what we really want to return back to. That's the physiological effect. The structural effect is almost nothing, because we already know that we can lose it. So on both grounds, there's no basis for assuming that. And I'm not saying we should, but I've certainly had it happen. We need to put a security system in for attack on our train stations with trucks laden with C4 explosives post 911. We just said drill. Sit in there with the auger and drill, and whatever you cut through, I'm sorry, you're going to cut through it, but it's probably not going to kill the tree, and it's probably not going to affect the long-term stability or health of the tree. 911, that was a fair time ago. Now, 14 years, we might be wrong. Come and see me in another 30 or 40 years, and I'll tell you if I am. Happy? So it's a set of guidelines. It's not an absolute. Having said that, when we transplant a tree, we do a lot worse. And I don't know whether I can do it quickly. I might have been able to do it really quickly by showing you some things, but this is an interesting one here. This is a transplant. They just move that with just nothing more than the trunk plus about 200 or 300 mils out. That we talked about these a few meetings ago. This is a brachychiton. They just treat them like garbage. Not saying that's what you'd want to do, but it just lets you know what you can do. So when you see how trees are mistreated all the time, I'm amazed. And if you look at bare root transplanting, You know, that's not a lot of material left on that. And people say to him, oh, yeah, but look, they've got all the fine roots. And I say, yeah, all the fine woody roots and almost no absorbing roots left. Why? Well, we found this magical chemical you add to fine woody roots that make them grow new pioneers and new absorbing roots. It's called water. And now we know about it. The secret's out. It really is amazing what that stuff does. And particularly if we make sure that it's not too wet and not too dry, we want the Goldilocks zone. How do you know what the Goldilocks zone is? The answer is look where the tree grows, look at its ranges, and somewhere in between the middle of those will be the Goldilocks zone. Yeah. So Peter Gray will, for example, tell you camphor laurel loves growing in high rainfall up to 2,400 mils, no problems at all. Camphor laurel does not like being saturated.
There's a lot of camphor around Lismore that have died after the recent floods.
Yeah, wet feet for a long period of time it does not like. Now, on the other hand, look at Clissamum viminalis. What a wonderful tree. Or Melaleuca quinquenerva, but I like viminalis because I've really got some experience in terms of seeing it in the Grafton River, in the boulders, knowing that it had been underneath water, and yet it's still alive. And yet Clissamum viminalis will grow relatively well in the dry areas of Sydney. It'll get down to 650, 700 mils rainfall. Boy, I know that it will tolerate and be quite happy at 1,200 mils. So if I was dealing with the Clissamum viminalis, 12 to 1,500 mils of equivalent rainfall irrigation, and it'll be a happy chappy. Make sense? And so that's what we want to figure out. Where are the extremes and what's the middle point, or the upper end of the middle point, and that's where it'll be doing well. Well, guys, if that's it for the night, I'll say goodbye. Nice to see you all. Tom, nice to see you there. And Rob, if you're still with us, good luck with the future. May life be wonderful and fantastic for you as it moves forward.